Hello students, this is Saxon, Algebra 2, Lesson 11a, which is called Addition of Fractions. Yes, we already know how to add fractions. But there is a twist because this is Algebra 2. Not a hard twist, but a twist nevertheless. Since I can't type fractions very well on PowerPoint, please follow along in your text. We're basically going to scan through Part A of this lesson. Page 62, the beginning. First, they show you an expression with three terms, all of which are fractions with numbers. Not only that, but they all also have the same denominator. Therefore, these terms are ready to be added algebraically, as you see in the next step, and the final answer is 2/11, 2 divided by 11. Next, they show you something very similar, but with algebraic expressions. Again, the denominators are the same, so we are adding them in the second step. The answer is parentheses 2a plus 5 close parentheses divided by b. That's the twist. Algebraic expressions instead of numbers. Algebraic expressions and fractions are handled just like you have handled numbers up to now. You need a common denominator. Once you have the common denominator, you need to decide what multiplier each term needs to get that common denominator. Remember that you have to multiply the terms by fractions that are equal to 1. Let's see how this plays out a little farther down page 62. If you can find the sentence that begins with, if we wish to add the algebraic fractions, it's near the bottom of page 62 and it's indented a little tiny bit, then you're in the right place. The problem is a divided by b plus c divided by x plus parentheses d plus e divided by 4. Now, remember that the fraction bar acts like parentheses, but it's always a good idea to put in the parentheses before you start manipulating algebraic expressions. Each term has a different denominator, so the common denominator will be 4bx. The first term already has the b in its denominator, so it needs 4x. So we multiply the first term by 4x divided by 4x, which equals 1. The second term has the x in the denominator, so it needs 4b. So we multiply it by 4b divided by 4b, which equals 1. The third term has the 4 in its denominator. It needs bx, so we multiply the third term by bx divided by bx, which equals, yes, you get it, 1. This is what is happening at the very bottom of the page, and they have finally put parentheses around d plus e. You can see the final answer there. At the top of page 63, you see clearly how 4x divided by 4x equals 1, etc. Whenever we multiply a term by a fraction that equals 1, like 4x divided by 4x, we are changing its form, but not its value. Changing the form is important so that the fractions can be added together over a common denominator. But it is important not change the value because that would ruin the equation. Let's look at the examples. Example 1, add k divided by 2a plus bc divided by ax squared minus m divided by ax cubed. The main challenge is finding the common denominator. We have these denominators to work with: 2a, ax squared, and ax cubed. They all already have an a, so that will be part of the common denominator. The first one has a 2, so that will have to be included. Now we have to choose between x squared and x cubed. In cases like this, always choose the variable raised to the highest power for your common denominator. X cubed equals x squared times x. It includes x squared, so that's why we choose it. The common denominator for this problem is 2ax cubed. Now we continue. The first term has 2a in the denominator, so we multiply it by x cubed divided by x cubed. The second term has ax squared in its denominator, so we multiply it by 2x divided by 2x. The third term has ax cubed already in place, so we multiply it by 2 divided by 2. This gives us k divided by 2a times x cubed divided by x cubed, plus bc divided by ax squared times 2x divided by 2x, minus m divided by ax squared times 2 divided by 2, which equals kx cubed plus 2bcx minus 2m divided by 2ax cubed. If you want to double check your work, simply separate out the 3 terms and each one gets its own copy of the denominator, like this. Kx cubed plus 2bcx minus 2m over 2ax cubed equals kx cubed divided by 2ax cubed plus 2bcx divided by 2ax cubed minus 2m divided by 2ax cubed. When you cross out the terms that appear in both the numerator and the denominator, you absolutely get the original problem, which means you've done it correctly. Example 2. Add m divided by k minus b plus cx divided by ak squared. Step 1, find the common denominator between k and ak squared. It has to have a in it, and k squared is the highest power of k, so it is ak squared. The first term already has k, so we multiply it by, no we don't, oh rat's a mistake. So we multiply it by, oh yeah, that's not a mistake, blah, 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 blah. Oh man, what do I do? Okay. Well, I gloriously messed up this slide. There's no way to save it. I'm going to end the program here and do example 2 in a simple little second video. So I hope that this recording has helped you to master the material up through example 1. Just ignore this slide. It's going to be in its own little video. See you then.